Good afternoon, one and all. So now I would like to say something about electrical system components. So here, so many electrical system components are there. So now we can see few components. So what are the few components like that? Few components. So basically components of LT switch gear. So components of LT switch gear, a low tension and high tension is there. So now I'm taking low tension. So low tension is a low voltage line and high tension is a high voltage line. So in India, LT supply is of 400 volts for the three phase connection, and the single phase connection is nothing but 230 volts for a single phase connection. So this is about components of LT switchgear. And next we'll see that there are four types of components of LT switchgear. So what are the four types of components? So the components is nothing but SFU. So what is SFU? SFU is nothing but switch fuse unit. So second one is nothing but MCB. MCB is nothing but miniature circuit breaker. And third one ELCB. ELCB is nothing but earth leakage circuit breaker. And fourth one, that is last, so molded case circuit breaker is nothing MCCB. Okay, so these are the four types of the components of LT switchgear. Okay, so now SFU. Now I'm taking first one, SFU, switch fuse unit. So the switch fuse unit, so this is the rewirable switch fuse units, and it is used for distributing the power and protecting the electrical devices. So what is saying here? So it is the rewirable switch fuse unit, and it is that used for distributing the power and protecting electrical devices and cables from the damage due to fluctuations. So if any damage is there, so it protects the due to fluctuations. And this fuse unit is housed in an enclosure made using quality CI cast iron steel sheet. So this is about switch fuse unit, SFU. So SFU is a rewirable switch fuse unit. SFU is nothing but rewirable switch fuse units, and it is used for distributing the power and protecting the electrical devices. From where? So protecting electrical devices and cables from damage due to fluctuations. So this fuse unit is housed in an enclosure made using cast iron silicon sheet. Next I'm taking here ELCB. So ELCB is nothing but earth leakage circuit breaker. So earth leakage circuit breaker, so it's in that compares phase and neutral wire currents. So it trips whenever there is uneven current. So what he's saying here, ELCB is nothing but totally it is nothing but earth leakage circuit breaker. So earth leakage circuit breaker, it compares phase and neutral. So the wires only currents, phase and neutral wire currents. So it trips whenever there is uneven current. Next we are taking MCCB. MCCB is nothing but mold case circuit breaker. So molded case circuit breaker. So molded case circuit breaker, basically this MCCB range is 63 amperes to 3000 amperes. So what is that? 63 amperes to 3000 amperes. So but in MCCB we can set the range. So but in MCCB we can set the range, the trip current from meter to MCCB, then to MCB. So what is that? So first of all, here the range of current 63 amperes to 3000 amperes. Suppose if we want to set the current range, so how we can set that? So we can set the trip current. We can set the trip current from the meter to current board meter to MCCB, then to MCB. MCB is nothing but miniature circuit breaker. So this is about MCCB. And next, now I'm taking here inverse time characteristics. In basically industrial electrical systems. In industrial electrical systems, so many contents. So what are the contents? So LT components, selection of switches, types of wires, and selection of wires, cables, LT components. LT components is SFU, MCB, MCCB, ELCB, and inverse time characteristics, isolator, relay, MPCB. So many things. So these are the contents in the available industrial electrical systems. So in the contents, so now I'm taking the first one here, inverse time characteristics. So next is inverse time characteristics. So in this inverse time characteristics, selectivity. So the selectivity, it helps the coordinate relay operations along a distribution systems. What he's saying, so inverse time characteristics, the first one, selectivity. The selectivity helps the coordinate relay operations along a distribution system. Okay, so that is the inverse time characteristics, selectivity. Next, in that further, time coordination. So the time coordination, so it allows downstream devices to clear faults before an upstream devices trip. What he is saying, so time coordination is the very simple thing. So what is that? It allows downstream devices to clear faults before upstream devices trip. So that is the time coordination. Next, avoid nuisance trip. Avoid nuisance trips. So here the nuisance, how to avoid the nuisance trips. So here we'll see that tolerates small overloads or temporary surges by the delaying trips. So how to avoid the nuisance trips? Tolerate the small overloads. Small, it can be only small overload. So or temporary surges by delaying trips. So for the continuation, a typical inverse time current characteristics curves. Okay, so in that the standard inverse is nothing but moderate inverse slope. Next, very inverse. So very inverse is nothing but stepper slope, trips faster for high currents. So very inverse, in that we are using here stepper slope, trips faster for high currents only. So next, extremely inverse. So extremely inverse, even stepper for high fault currents only. So here three things, typical inverse time characteristics curves. So in that the first one, standard inverse, what will be taken here? The standard inverse, moderate inverse slope. So next, very inverse. So very inverse is nothing, stepper slope, trips faster for higher currents. Okay, next, extremely inverse. So extremely inverse, even stepper for higher fault currents. So these are the typical inverse current characteristics curves. So basically Three things are involved in that. So here the mathematical representation. So from the mathematical form, so here t is equal to k into a power 1 minus 1. So here that where t is equal to operating time in the seconds. So I is equal to, where I is equal to operating current, measured current, I is equal to measured current. So operating time is nothing but t. So and I is equal to, we can measure the current, so I is equal to measured current. So and next a is nothing but constants depending on relay type. So we have so many types of relays. So it is a is nothing but constant depending on relay type. So here standard relay, very inverse, and extremely inverse. So these are the relay type of the a is nothing but constant. So mathematical form, so t is equal to k into a power minus 1 into t. Okay, so here t is nothing but operating in seconds, operating time. Okay, so and next I is equal to, we can measuring the current is nothing but measured current, and a is equal to constant. So it constant depending on purely relay type. So here the relay is nothing but here standard type relay, and very inverse relay, extremely inverse. Okay, so this is the mathematical form of the typical inverse time characteristics. So next, so what the curves the look like? So the curves look like on the y-axis. So on the on the x-axis, it will be only representing normalized current only, and the y-axis it's representing operating time. So time in seconds. So at the currents just above the pickup, the relay trips after a long delay. So a current increases, operating time decreases sharply. And so the curve here, what the curve look like, so both axis and x-axis, y-axis. On x-axis, so here the measured current only, it is nothing but normalized current, and y-axis, so the y-axis here operating time, so time in seconds, operating time. So at the currents just above pick up the relay trips after a long delay. So as a current is increases, operating time decreases sharply. So next I'm taking here contactor. So what is contactor? How it will works? And what are the key points involved there? Okay, so next what is contactor? So what is contactor? So contactor is nothing but it is an electrically controlled switch. So what is that? Contactor is nothing but electrically controlled switch, and it is used for switching power circuit. So it is commonly used to control electric motors, lighting, heating, and other electrical loads remotely. So here the electrical loads, so many load, inductive loads, resistive load, capacitive load, so many things are loads. So what is saying here? So contactor is an electrically controlled switch. So electrically controlled switch, and it is used for switching a power circuit. It is commonly used to control electric motors, lighting, heating, and other electrical loads remotely. Okay, so this is about only for a definition of the contactor. So next, how it will be works? Okay, we'll see that how it will be works. So when a control voltage is applied to the coil, so when a control voltage is applied to the coil, so the contactor closes its contacts, allowing current to flow in the power circuit. So then when the coil is de-energized, so the contacts open and interrupting the current. So this will be this will be happens that working condition. Okay, so what is the working condition? So when a control voltage is applied to a coil, so that is the first thing. So we are a control voltage is applying the coil, so the contactor closes the its contacts and allowing the current to flow in the power circuit. So when the coil is de-energized, so the contacts is open and interrupting the current. So this will be happens the working condition contactor. Okay, so what is the key point involved in this? So the key point involved in the contactor, so the designed and handle high current loads repeatedly and safely. So what we have designed the and handling high current loads, so this will be repeated and safely and securely. Okay, so designed to handle high current loads repeatedly and safely. So once again see that here contactor definition. So what is contactor device? Contactor is a electrically controlled device. So electrically controlled device, and this electrically controlled switch is used for switching power circuit, and it is commonly used to control electric motors, lighting, heating, and other electrical loads. Isolator. So isolator is nothing but isolating switch. So what is this? So what is the isolator switch? How it will be works? So what is the key point involved in the isolator? So now we'll see these 3 points. So first of all, what is isolator? Okay, so what is isolator? A manual switch is used to ensure that an electrical circuit is completely de-energized and a maintenance of the safety purposes. So what he's saying here, a manual switch is used to ensure that an electrical circuit is completely de-energized for maintenance or safety purposes. Okay, so this is nothing but isolator or isolating switch, so both are same. So now we'll see that how it will be works. So how it will be works, so it physically disconnects the circuit from the power source. Power source is not voltage source or what it nothing but power source. So it physically disconnects the circuit from power source and providing a visible gap confine the circuit is off. Okay, so what is that? What he's saying here, it physically disconnects the circuit from the power source, providing a visible gap to confine the circuit is off. Okay, so here the what key points so involved in that we'll see right now. So used only, so the key point of this isolator or isolating switch, so it is used only when the circuit is not under load condition. So under load condition is nothing but not intended for switching under load. So now see that a relay. So basically relay is nothing but so many type of relays. So what is the relay? Relay is nothing but it detects the fault function. It detects the fault function is nothing but relay. So relay, what is relay? So an electrically operated switch used to control circuit by a low power signal, or where the multiple circuits is need to be in the control by one signal only. So what is saying here, an electrically operated switch is used to control a circuit by a low power signal, or where the multiple circuits need to be controlled by one signal. Okay, so here so many types of relays: electromagnetic relay, solid state relay, thermal relay, so many types of relay. So here, how it will be works the relay, we'll see that. So when a small current energizes the coil, solenoid or coil, both are same. So when a small current energies the coil, so relay changes the state of its contacts to open or close another circuit. So when a, what he is saying, when a small current energizes the coil, the relay changes the state of its contacts open or close to another circuit. Okay, so here in this the key point involved that, what is that, it used for only protection, control and automation purposes only. So there are here the key points are involved in three ways. So what is that? Protection, controlling and automation. So these are the three process, the way to key points. MPCB. So what is a MPCB? MPCB is nothing but molded case protective breaker. Okay, so MPCB, molded case, and sometimes it's called as motor case also. So what correct exact word is nothing but molded case protective breaker. So what is MPCB? Okay, so a type of a circuit breaker designed to protect electric motors from overload and short circuit and phase failure. So what is that? So a type of circuit breaker designed to protect electric motors from overload, short circuit and phase failure. So this is nothing but MPCB, molded case protective breaker. Okay, so how it will be works? How it will be works in the environment? So the how it will be works? So it automatically trips or disconnects power when current exceeds. If anywhere the current is exceeds, so preset limits to protect the motor and wiring. So here important is nothing but how it will be works in the environment. See, so automatically it trips is nothing but disconnects the power. So when current exceeds preset limits to protect the motor and wiring systems. Okay, so next, so what is the key point involved in the MPCB? So what is the key point involving? See, so it combines in the overload and short circuit protection in a compact device. So what is that? So it combines overload and short circuit protection in a compact device. So once again we'll see that MPCB is nothing but molded case protective breaker. Okay, so what is MPCB? So MPCB is nothing but a type of circuit breaker designed to protect electric motors from overload, short circuit and phase failure. So how it will be works? So it automatically trips. Automatically trips is nothing but it disconnects the power. So it disconnects the power when the current is exceeds. So when the current is exceeds preset limits to protect the motor and wiring systems. Okay, so in that the key point involves it combines overload and short circuit protection in a compact devices. Next, here electric shock. And nowadays and olden days, we are seeing electric shock. How the man is shocked from the current. Okay, so what is a shock? Electric shock. So what is that? So an electric shock, it occurs when a person's body becomes, what is that? An electric shock occurs when when a person's body becomes part of an electric circuit, causing current to flow the body. So hazards. So can cause burns, nerve damage, cardiac arrest or death. So what is that? From the electric shock hazard. So what type of hazards? So it can cause burns and nerve damage and cardiac arrest, or sometimes death conditions also. Okay, and the severity depends on amount of current, duration of exposure, and path of current through the body. So electric shock. So basically nowadays or olden days, we can see or seen that. Next, here you can see that references. So which textbook we can involve? We can refer that. So the textbooks. So S. Singh and R.D. Singh, Electrical Estimating and Costing, Dhanpat Rai and Company. So 1997. So second, website for IS standards 3H Joshi, residential, commercial and industrial systems. So that is MC Grahil Education 2008. Thank you.